Okay guys, in this video we're going to look at finding the surface area and volume of cones this time. And so we have a cone here. So a cone looks something like this. You know, I think we're fairly familiar with cones. We see a lot of cones in the real world. You know, like in a traffic situation we see cones, or a party hat, we know what cones are. So these are what cones are. And then what we have here, here is actually a laid out version. If you were to smash down a cone, what it would look like. So this circle here would be the base, and then this sort of shape here would be the actual part that wraps around the cone. So if you actually take apart a cone, and of course if it has a base, then that's what it would look like. So the anatomy of a cone, then, what do we call all these things? Well, we have up top here, we have the vertex. Okay, we have then from the vertex at a 90-degree angle comes down. That's the height or the altitude. Okay, we can sometimes also call that the axis. Okay, and then here is the base. All right, and then what that looks like then practically. Okay, over here is L, and then when we actually smash that down, what it looks like is given here. So we have this part is 2 pi. Here is L, and then of course we have the radius for the base. So what did the problems or the formulas actually look like? Well, we have volume equals 1/3 pi r squared h. Now that's very similar. Remember, we've been talking about pyramids and cones are very, very interrelated. And so if you think about a cone as a pyramid with a circular base, okay, then all we've done is basically replace you know, the area of the base, part of the volume of a pyramid, with the area of a circle. So it's just a more specific application of the volume of a pyramid. Volume of a pyramid, again, is 1/3 area of the base times height. And if you think of a cone as a pyramid, then this would be pi r squared. And then, of course, times h. Now, the surface area is a little bit different. Of course, we have pi r squared. So pi r squared here is going to be the base, obviously, the circle, and then pi r l. Now, where does that pi r l come from? So this is a little bit tricky. Well, let's go ahead and look at this. Okay, so imagine we have, in here we have a very big, you know, section of a circle, or we have a very big cone. But imagine if our section is only very, very small. All right, and so it's going to look something like that. So just imagine with me for a moment. Okay, then this distance is going to be, it looks like this distance is going to be 2 pi r. And again, if you see here, imagine if we shrink this down into a little wedge, then this distance here is 2 pi r, and then this is going to be L, right? So again, we see right here is L, and so that would be here. Now, if we shrink this into a very, very, very small cone, it looks very, very, this part of the cone looks very similar to a triangle, okay? And so we know that the area of a triangle equals 1/2 base times height. Well, here we have 1/2 times the base. The base would be 2 pi r. And the height, well, we don't actually, it looks like we have this leg here, right? That's L, but do we actually know the height? Okay, well, if we look back here, think about all of this line and this line and this line and this line. All of those lines are L. So every line here from this point to this line, every one of those lines is distance L. So this line is L, this line is L, this line is L. And so the height is actually L as well. And so we can use L for the height. And so we get 1/2 times 2 pi r times L is just pi r l. So let's go ahead and look at a problem here, what this looks like, you know, practically speaking. Here we have a cone. Height is 9, radius is 3. Okay, so we have to just plug in our numbers. Volume equals 1/3 times pi. Again, r is 3. H is 9. Okay, so we just finish off the problem here. We get 1/3 pi. This is 9. 3 squared is 9. Times 9 is 81, which equals 27 pi units cubed. All right. Also, surface area then, we need to know, let's see here, surface area equals, so this is going to equal pi r squared. Well, pi is pi and r is 3, so pi r squared plus pi times r, so 3, okay? And now we need to know L. Well, we don't have L, we have the height, we have the radius, so we can use Pythagorean theorem here. All right. So this is going to be 9. This will be 3. This is L. So 9 squared plus 3 squared equals L squared. So 81 plus 9 equals L squared. So L equals, that's going to be 90. So if you root 90, that'll be root 90. Okay. We can reduce root 90 to 3 root 10 equals L. Okay, so L is going to be 3 root 10. All right. So this is going to be, it looks like 9 pi plus 3 times 3 is 9, so 9 root 10 pi. And this is going to be units squared. So of course you can factor out a 9 pi here. There are different ways to write that, but certainly this would be an acceptable way of leaving your answer. And I just wrote parentheses here just to be careful that this whole thing is going to be units squared and not just here. So technically you should leave your answer with parentheses around it if there are 2 terms, but in practice oftentimes we don't, but that would be our technical correct answer. So just looking then at another example here, we have another cone. This time we're given the slant height and we're given the radius. So the slant height is 10, radius is 3. So this time, because I'm given the slant height and the radius, I'm going to start with surface area and then work back to volume. So our surface area is going to equal, it looks like pi. R here again is 3, so 3 squared plus pi times 3 times L this time is just 10. So we get 9 pi plus, looks like 30 pi. So 9 pi plus 30 pi, that equals 39 pi units squared. Okay. Now if we're looking at the volume, we need to know the height. We need to know the height. And so before we work on this problem, we need to know what our height is, but we don't have that. So we can use Pythagorean theorem. Here we have, again, the radius is 3. The slant height this time is 10. And we need to find the height. All right. So we can use Pythagorean theorem. We know 3 squared plus h squared equals 10 squared. And again, the only real confusion with Pythagorean theorem is where we put these different values. Okay, so make sure you do leg, leg, hypotenuse. Leg plus leg equals the hypotenuse. So be careful there. So we get h squared. This is going to be 9 and 100, so this will equal 91. Okay, so h equals root 91. And again, technically if you're in algebra class, you would put plus and minus, but we know that distance can never be negative, so you have to kind of apply that to this specific problem. So this is going to be, let's see here, volume will equal 1/3 pi times r squared times h. Okay. So this is 9. All right. 9 times 1/3, or 9 divided by 3, is 3. Okay, so this is 3 root 91, 3 root 91 pi units cubed. All right. Hopefully this gave you guys a decent idea about the formulas of our surface area and volume formulas of a cone. And we worked through where those come from and then a few problems. It's often common that you'll have to do some sort of Pythagorean manipulation to obtain either height or slant height, because it probably won't be given to you except for in the very easiest of problems. but hopefully this gave you an idea of what the formulas look like and how to use them a little bit. Thanks for watching.